Hello everyone, this is Professor Mahesh Pardeshi from Parvatibai Genba Mose College of Engineering, Wagholi, Pune. In the today's lecture, we see with the design philosophy. In that, first is the working space method, second is the ultimate strength method, third is the limit state method. Now, we will see it one by one. That is, first is working space method. It is the one of the oldest method of design suitable for all the structures. True, though IS 800-2007 insists for the design limit state design, which permits the use of this method wherever LSM, that is limit state method, cannot be conveniently adopted. Example is water tank. In case of design of water tank, we cannot use limit state method. For the design of water tank, we have to use this working space method. With the development of linear elastic theory in the 19th century, the stress-strain behavior of material is considered as linear till the yield stress. To take care of uncertainties in the design, permissible or allowable stress is kept as a fraction of yield stress by the ratio known as factor of safety, so that the members designed are to keep the stresses within the permissible value. Here in the working stress method, safety is ensured by limiting the stress of the material, and the material is assumed to behave in the linear elastic manner. In this approach, the stress strain behavior is considered to be linear. Therefore, in case of working stress method or permissible stress, the allowable or permissible stress is equal to yield stress divided by factor of safety. Means in case of WSM, in case of WSM, for the calculation of permissible stress, we have to use the formula, that is yield stress divided by factor of safety. This is all about the working stress method. Now we will see the advantages and limitations of working stress method. Let's see. First part is advantages of working stress method. The first advantage is this method is simple. What is the meaning of simple method? Means the design procedure used in case of WSM is very simple. Now, second one is this method is reasonably reliable. What is the meaning of reliable? Means we can trust on it. The design which is made by using the working space method, we can rely on it. And third one is, as the working spaces are low, the serviceability requirement are satisfied automatically. What is the meaning of it? In case of working space method, the stresses are very low, so that the design is serviceable. Means we have to no need to design another method or no need to design another steps, another steel to count for the serviceability. No need to go for that. These are the advantages of working stress method. Now we will see the limitations. The first limitation is the assumption of linear elastic behavior, and the stress under the working loads can kept within the permissible stresses are not found to be realistic. So see, in the first limitation, While designing the structure by using working space method, we assume that the material is linear elastic, means the behavior of the material is linear elastic. But as such in practice, in the real life, it is not possible. So this is the limitation of working space. Another this said that the stresses under the working loads can kept within the permissible stresses are not possible real life. What is the meaning of it? The stresses, we consider that the stresses are within the working load or within the permissible limit. But in practice or in actual, the stresses may exceed their permissible limit in some cases. In case of accidents, in case of some unfavorable condition, these stresses may exceed their permissible stress limits. That's why this is not practically possible. So this is the limitation of working stress. Second is it gives uneconomical section. Uneconomical section means what? The design by using working space method is heavy. Means it gives heavy sections and heavy sections require heavy money. That's why the design which is made by using working space is uneconomical. Third limitation is this method does not consider material non-linearity. See, we consider the material which is linear elastic behavior. But see, in practice, the material should not behave or should not behave in elastic linearity. Means the properties of the material may vary. So this point is not considered by this method. This is the limitation of this method. Next is this method does not provide a realistic measure of the actual factor of safety for the design. This method, see, this method considers the factor of safety fixed for a particular type of section. Like for beams, the factor of safety is 1.67. For columns, factor of safety is 1.92. For short columns, factor of safety is 1.67. And for connections, factor of safety is in between 2.5 to 3. But in actual site conditions, the stresses may vary. This variation is not considered by this method. Okay, this is the limitation of this method. Last point is many factors like effect of stress concentration, creep, shrinkage, residual stresses, and the other secondary effects are not considered. So, in this method, the design is purely based on the working loads and no other conditions they considered while designing. What are the other conditions? Like stress concentration. What is the meaning of stress concentration? Means the concentration of stress at a particular point in the section. Means at some point the stress concentration is less and some other point the stress concentration is large or more. This effect is not considered by this method. Second is creep. Creep is nothing but the time dependent deformation of the structure. As the time passes, the deformation goes on increasing. That is nothing but the creep. This point is also not considered by this method. Next is shrinkage. Shrinkage is nothing but the volume change, effect due to temperature or anything. Effect on the structure due to temperature like volume change. This is nothing but the considered by this method. And other points also like residual stresses and other secondary effects are not considered by this method. These are the limitations of working stress method. That's why this method, there are large number of limitations of this method. That's why this method is outdated, not used right now. Now, next is the ultimate load design. See, the limitations of the working stress method to determine the actual load carrying capacity and made the researchers to develop the ultimate load method. And this method is also called as plastic design method. Now see what happens in this method. In this method, a section is said to have the form plastic hinges when all the fibers are filled, but the structure continues to resist load until sufficient number of plastic hinges are formed to transform the structure into a collapse mechanism. At this state, the load is known as ultimate load. At this state, the load is known as ultimate load. And some this reason is also the for that reason also the name is given as ultimate load method. Again, safety measures are introduced by using load factor. Means in this method, the safety measures are introduced by using the load factor, which is defined as the ratio of design load to the working load. Means the load factors are defined as the ratio of design load to the working load. These load factors are given in IS 800. And just simply we can find the ultimate load, which is the summation of, here the summation sign is missing at this place. At this place there is a summation sign. Summation of working load into load factor. Means we have to add all the working load and their load factor. Means working load into multiply by load factor, which gives us the ultimate load. Now the load factors are depending upon the load combinations. When we have to use dead load, the load factor is 1.7. When we have to use dead load plus imposed load, in that case also the load factor is 1.7. Or when we use dead load plus wind load or dead load plus earthquake load, in that case also the load factor is 1 by 1.7. And in case of dead load plus imposed load plus wind load, means combination of three loads, that is dead load plus imposed load plus wind load, or dead load plus imposed load plus earthquake load. In that case, the load factor is 1.3. This is all about the ultimate load method or ultimate load design. Now we will see the advantage of this method. Here, the first advantage is due to plastic hinge concept, the redistribution of the internal forces is accounted. Now, see the redistribution. What is the meaning of redistribution? Here, redistribution means distribution of the internal forces to the various points within the section. See, see properly. Huh? When the section is loaded, some part of the section is less loaded and some part of the section is more loaded. So there is an imbalance between the different points within the section for the internal force. So this plastic hinge concept means these plastic hinges transfers the extra load at the point where the internal forces are more to the another point where the internal forces are less in order to balance the internal force within the section or throughout the section. This is the advantages of ultimate load method. Now, second is it allows varied selection of load factors. Now, see in case of WSN, the load factors or factors of safeties are depend on the sections, that is being column, short column, long column connections. But here in case of ultimate load method, there we can use variation of load factors depending upon the various conditions, site conditions, stress condition, loading condition, all of these. So this is also the advantages of ultimate load method. Now we will see the limitation of ultimate. Next point, limitation of ultimate load method. The first limitation is limitation on deflection, and also it does not guarantee the other serviceability limits like instability and fatigue. Means in this method, ultimate load method, there is a limitation of on deflection. Means we cannot permit the heavy deflection in case of ultimate load method. As the deflection increases, the member fails or our design fails. That's why we cannot use heavy deflections in this case. Means deflect, there is a limit on deflection. We can consider only the small deflection in case of this method, ultimate load method. Okay. Other serviceability limits. Serviceability limits mean what? First, you see that there are two parts in any design. First part is strength and second part is serviceability. So while designing any structure, we have to design for strength also, and we have to design for serviceability also. Means suppose there is one section which we have to design, so it must take that much of load which is coming on it throughout its design life. That is nothing but the design for strength. Now what is the meaning of design for serviceability? Means we have to design the structure in such a way that that structure should be serviceable throughout its design life. Suppose we have to design one structure for 100 years of life. So design for serviceability means what? Thus we have to design the structure in such a way that the structure should be serviceable for 100 years. For its design life means what? For 100 years. That is nothing but the design for serviceability. But see, in this method, that is in this method, that is ultimate load method, they are not considering the serviceability requirement. They are considering only the strength. They are not considering the serviceability requirement. Okay, this is the limitation of these methods. Now, next is limit state method. This method is very useful. Means we have to design the structure by using this method only. Now all the structures are designed by this method. Now see, let us see this method, that is limit state method. IS 800-2007 is applicable to the structural use of hot rolled steel is largely based on the limit state method. However, it still retains the working state method where LSM cannot be adopted. LSM cannot be adopted means I have already given one example for that. That is the water tank. Okay, in case of water tank, we cannot go for this limit state method. Always we have to design the water tank by using working stress method only. Now, the limit state method of design developed to take account of all uncertainties that can make the structure unfit for use by considering the actual behavior of material and structure. In the limit state method, basically statistical methods have been used for the determination of load and the material properties with a probability of structure reaching the limit state of strength and serviceability. However, it is not yet possible to adopt a complete probability basis for design, and therefore the method adopted partial factors of safety which are introduced to take account for all the uncertainties. In this method, we have to use the partial safety factors to consider all uncertainties, to account for all uncertainties. See, in the limit state design method, the structure is designed in such a way that it can safely withstand all kinds of loads that may act on the structure under consideration in its entire design life. In this approach, the science of reliability based design was developed with the objective of providing a rational solution to the problem of adequate safety. This is all about the limit state method. Now, what we do in this method, we have to omit the limitations of first two methods, that is working stress method and ultimate load method. We have to omit the limitations of these two methods in this method. That's why this method is very good method for the design. It gives best results. Now we will see the advantages of limit state method. First advantage is in this method possibility of materials non-linearity, structural non-linearity, calculation error are considered. See, in this method all these points are considered. How we will say that? Because see the next line. Factor of safety is called as partial safety factors which are determined by the statistical analysis. Means here we have to use the partial safety factors which are accounts the material non-linearity, structural non-linearity, and also they account for the calculation error. Okay, and these safety factors are not fixed just like a working stress method and ultimate load method. In that method we will see the load factors and factor of safety are fixed for a particular type. But here in this case we can adopt the safety factors which are called as a partial safety factors for individual loads, that is it is different for many types of load, that is dead load, live load, wind load. Again, for different types of material we have to use the different settings. Next is this method provides a realistic measure of the actual factor of safety. See, in this method we use the, while we are using the partial safety factors, they give the actual result. These partial safety factors give us actual results. That's why this method provides a realistic measure of the actual safety. Okay. This method designs any structure for strength as well as serviceability criteria. Means see, this is the disadvantage or limitation of ultimate load method. Ultimate load method cannot account for the serviceability criteria. Ultimate load method accounts for only strength. But see, in this method, that is the limit state method, this method accounts for strength as well as serviceability, both the things. This is the advantage of LSM. And last is this method considered reverse strength of material beyond the elastic limit of restraint curve. See, the material when loaded, first of all, it gives the elastic behavior within the restraint curve. Means, what is that elastic limit? When the load is removed, the material gives its original size and shape. That is called as elastic. That is the meaning of elastic. Means when the load is removed, the material gets its original size and shape. This is elastic. But in this method uses some other strength beyond that elastic limit. Means the strength of the material is maximum utilized in this LSM. This is the advantage of this method. So this is all about the LSM, and we already see the advantage of LSM, why we have to go for this, because this method accounts for all the limitations which are occur in case of WSM and in case of ULM, that is ultimate load method. Means this method is very useful for to omit the limitation of all these methods. All of you understand these points? Okay, thank you.